Welcome to aminacademy.com. In mathematical formulae, let us discuss about system of linear equations. Before talking about system of linear equations, we have to understand the variable first. Let us take the variables as x, y, z, or x1, y1, z1, like that. Real numbers. Best in terms of A1, A2, A3, B1, B2, B3, like. Still even A11, A12, A12, A13, like we can tell these are real numbers. Determinant. Determinant is written as d, dx, dy, dz, like we can indicate. Now, the general form of linear equation in two variable, look at here, a1x plus b1y equal t1. Second equation may be written as a2x b2y equal d2. Like this. From this we can see what is Cramer rule. By using these two equations we can solve by using Cramer's rule, that is, let x equal dx, determinant x with divider of d, y is dy over d. Now let us discuss about further about Cramer's rule in following paragraphs. Next one, what is linear system of linear equations? A system of linear equations is a mathematical concept involving two or more linear equations that share the same variables. These equations collectively define a relationship between variables, often representing lines, planes, or higher dimensional surfaces in space. The solution of the system is the set of values for the variable that satisfies all equations simultaneously, typically corresponding to points of intersection or commonality among the equations. Look at here. Suppose in XY graph, two parallel lines, that solution, no solutions, because there is no intersection point. It's called inconsistent system of equations. Here one solution, because it intersect, that two lines intersect at one point, then this is one solution. And here infinite solutions, because there is no solution, because two lines overlap, that means only one line forms, so it calls no solutions. This is consistent, these are all consistent in that it's independent, it is dependent. Now let us discuss further about Cramer's rule. The Cramer's rule is one of the methods used to solve system of equations. This rule involves determinants. The value of the variable in the system are found with the help of determinants. Let us consider a system of equation in n variables, that is x1, x2, x3 up to xn. These are variables written in the matrix form Ax equal to b. Here, where A is the coefficient matrix of the system of equation, which is the square matrix. X is the column matrix with variables, that is x1, x2, x3, like. B is the column matrix with the constant which are on the right side of the equations. Here, the Cramer's rule formula to solve the equation Ax equal to b, or to find the values of the variables x1, x2, x3 of xn, solve the system of equations. First, you have to find determinant of A. to represent D. Find the determinants dx1, dx2, dx3, dxn, where dx is the determinant of matrix A, where the ith column is replaced by the column matrix B. We divide, that is x1 equal to dx1 by d, x2 equal to dx2 by d, like xn equal dxn by d. This is the solution of this system of equation. Note that the system of equation has a unique solution only if d is not equal to 0. Even there is a system of 3 into 3 system also we can solve. Now, in generally, look at here, the system of equation ax1, a1x plus b1y equal d, a2x plus b2y equal d2. This is a system of equation in two variables. Now we can find by Cramer's rule. Is like d. First, x equal dx over d, y equal dy by d, where d is the determinant of the coefficient matrix. This is a1, b1, a2, b2. a1, b1, a2, b2. Then determinant x, which means it's a determinant of 22 order, having that here we have to avoid this x coefficients and use these two things. That's b1 d1, then b2 d2. Next is determinant of y, means don't take this y coefficients, then x and d, that is a1 d1, a2 d2, a1 d1, a2 d2. By using these three determinants, we can use to solve what is x and what is y. We know that this value d is the cross multiply a1 b2 minus a2 b1. Here b1 d2 minus b2 d1. Or here a1 d2 minus a2 d1. Now consider the system. If d is not equal to 0, that means if d is not equal to 0, as well the system has single solution. System has single solution, that is x equal dx over d, y equal dy over d. If d equals 0, what happened? If d equals 0 and d equal to 0 and dx not equal to 0 and dy not equal to 0, if this condition satisfies, then you can say the system has no solution. System has no solution. That means this determinant equals 0, d is equal to 0 and dx is not equal to 0 and dy is not equal to 0, then you can say the system has no solutions. Now if that condition, if d, determine d equal dx equal dy, then all are 0, then we can say the system has infinitely many solutions. The system has infinitely many solutions. Which means the line overlaps. Well, there's three systems. First one, d is not equal to 0. This system has single solution, and that solution is dx equal to dx by d, dy equal to dy by d by Cramer's rule. If d equals 0, then dx is not equal to 0 and dy is not equal to 0. The system has no solution. And if d equal to dx equal dy equal 0, all are 0, the system has infinitely many solutions. Next one, matrix form of system of n linear equation in n unknowns. Suppose how to form this equation in matrix form with n unknowns. Look at here. The system of m linear equations in n unknown, note that m and n need not be equal, may be equal or may not be equal, can be written as ax equal to b. This is a matrix equation form where a is the mn coefficient matrix of the system, of x is the vector consisting of n unknown, and b is the vector consisting of m right hand side of the equations as shown below. Look at here, the system of linear equation given as a1, a11, a12, a13, a14, a21, a22, all coefficients written in form of matrix. This, let it be this a coefficient matrix. Then x equal, it's a column matrix of variables x1, x2, x3 up to xn. B is the equation coefficient equation of that right side right side values, which is equal matrix B equal b1, b2, b3 up to bn. Then you can write ax equal to b is the matrix equation to solve the system of linear equations. Even the Cramer's rule can be used for any number of variables system of equations. Next one, solution set of linear equation. That is generally x equation, x values equal A inverse B. This x is a solution matrix which is equal A inverse of A matrix into B. That means here the system of equations, this matrix A is here, B is here, then A x matrix is here, B matrix here. Then finding the values of X matrix is equal A inverse. We have to find the inverse of this system matrix of the square matrix multiplied with B matrix. We can get values of X matrix. So far, we simply discussed about what is linear equation, system of linear equations and their solution with Cramer's rule. And we discussed about matrix of the system of n linear equations in n unknowns. We have done. Please subscribe our YouTube channel.